Horizontal translation will play out very similarly to vertical translation, but with a twist. When we want to transform something horizontally, we're going to affect the x-coordinate. To translate to the right by c units, we'll add c to the x-coordinate. So in this diagram, h is what we get when we translate f 3 units to the right. We've taken every x-coordinate on the graph of f and added 3 to it. We've moved every point 3 units to the right. To translate to the left, we subtract our number from the x-coordinate. So k is the result of translating f 4 units to the left. We took the x-coordinate of every point on f, subtracted 4 to move it 4 units to the left. So we're going to go through our graphs point by point and see what's happened to each point on the graph. And based on that, we're going to see what has happened to the actual expression for f to get the expressions for h and k. So looking at the key points on the graph of f, we have a point at -4, 1, so f of -4 is 1. We have a point at -2, 2, so f of -2 is 2. We have a point at 2, -4, so f of 2 is -4. And then we have a point at 5, -2, so f of 5 is -2. Let's look at what happens to each of these points when we translate 3 units to the right to get h. We have -4, 1 on the graph of f. Translate that 3 units to the right, and we have -1, 1 on the graph of h. So h of -1 is 1. We had -2, 2 on the graph of f. Translate that 3 units to the right, and we have 1, 2 on the graph of h. So h of 1 is 2. We had 2, -4 on the graph of f. Translate that 3 units to the right, and we have 5, -4 on the graph of h. So h of 5 is -4. Finally, we had 5, -2 on the graph of f. Translate that 3 units to the right, and we have 8, -2 on the graph of h. So h of 8 is -2. Okay, so the outputs then have stayed the same, and the inputs are all 3 more. Just exactly as we would have expected, since we've added 3 to every x-coordinate. So we might be thinking, is it f of x plus 3? But let's look at this more carefully. When we took h of -1, that was the same as f of -4. We didn't take the input of h and add 3 to it. We said, what do we need to add 3 to in order to get the input of h? In other words, h of -1 is not f of -1 plus 3. It's f of -1 minus 3. We're putting -1 into h, which gives the same result as putting -4 into f. When we want to find the input of f, we have to go backwards. H of x is f of x minus 3. To go 3 to the right, we had to subtract 3 inside the function. That's a little bit weird, but I think we can get used to it. Let's see if we follow the same pattern when we're going to the left. So we have -4, 1 on the graph of f. 4 units to the left of that, we have -8, 1 on the graph of k. So k of -8 is 1. We had -2, 2 on the graph of f. 4 units to the left of that, we have -6, 2. K of -6 is 2. 2, -4 on the graph of f. 4 units to the left of that, we had -2, -4. K of -2 is -4. And then we had 5, -2 on the graph of f. 4 units to the left of that, we have 1, -2. So K of 1 is -2. Again, the outputs are the same, but the inputs are 4 less. When we wanted to take K of -8, that's the same as f of -4. How do we go from the input of K to the input of f? We have to add 4 to it. So K of x is f of x plus 4. Again, backwards, because we need to go from the input of K back to the input of f. So horizontal translation, if we have f of x minus c, that means we need to translate c units to the right. If we have f of x plus c, that means we need to translate c units to the left. So if we subtract something, that's a translation to the right. If we add something, that's a translation to the left. Right is usually the positive direction, so this is backwards. The direction of the translation is the opposite of the sign of the number that we're adding. And again, that's because we need to go from the input of the new function back to the input of the old function.